Good afternoon, everyone, and thank you for being here. I hope the coffee has been kicked in and you are all excited for this session. I'm Kanika, and together with my colleague Jasjit, we are here to share a story that I think a lot of you will find familiar. It's a story about inheriting stable system, hitting a wall, and figuring it out how to modernize it anyway, under real scale, at real constraints. The talk is called From ESXi to Kubernetes at Edge, Modernizing 1,400 Distributed Locations. And I really want to emphasize on the number 1,400, because these are 1,400 retail stores nationwide. Each one is a live production environment. For those who may not be familiar with us, Loblaw is Canada's leading food and pharmacy retailer. We serve millions of Canadians every week through a network of grocery stores, pharmacies, and digital platforms that span across the country. Loblaw has over 2,800 locations, generating a 61 billion revenue. We're doing more than billion customer transactions per year, and we are a healthcare partner to more than 20% of Canadians. Our portfolio includes well-known brands like Loblaw's, No Frills, Joe Fresh, Shoppers Drug Mart, and PC Financial. Each division playing a critical role in how Canadians access their everyday essentials. Joe Fresh is our clothing and apparel line of business. PC Financial is the banking institute, and Shoppers Drug Mart is the pharmacy business and the core business for today's talk. Shoppers Drug Mart is a network of 10,000 healthcare professionals caring for 11 million Canadians. At the scale we operate, reliability isn't just the technical goal. It's directly tied to how Canadians get their prescriptions and the services that they depend upon daily. And that's exactly where site reliability engineering becomes essential. So what led to the transformation from ESXi to Kubernetes? We weren't trying to modernize just for the sake of modernization. The system we had was very stable and was running on our stores reliably for years. Each location had its own small ESXi-based environment running critical pharmacy and point-of-sale workloads. Across the country, that meant roughly around 1,400 distributed edge locations had their own ESXi environment. The first pressure came from the cost. Virtualization licensing costs increased significantly, and the economics no longer made sense at that scale. But cost wasn't alone the only problem. The existing platform was fundamentally designed around virtual machines, and that made application modernization very difficult. Running containers, adopting microservices were not a natural fit in this environment. So while the platform was stable for today, it would have become increasingly expensive for tomorrow, and it effectively limited our ability to modernize. That's what ultimately pushed us to explore a different approach. With that context, I'll pass it to my colleague Jasjit to take you through what we did next.
Thank you, Kanika. That was a great overview of the business and the problem statement. So for those I haven't met, I'm Jasjit. I'm part of the Loblaw's team, and I have worked on the Edge modernization initiative we are presenting today. I'll take it up from here and walk you through the journey ahead. To understand why this migration was complex, it will help to understand what a typical store looked like before we even started. Each store had a self-contained ESXi environment, usually 2 physical nodes, a shared storage, and multiple virtual machines running business-critical workloads. And these stores had to operate even in case of connectivity loss to a data center or cloud. The applications themselves were mostly traditional enterprise workloads, Java applications, DB2, and point-of-sale systems, all running inside VMs. Monitoring was also very tightly coupled to the platform. We were using a proprietary tool from IBM called as ITCAM. The current system was optimized for stability, but not flexibility, which is exactly why replacing it safely was hard. So it wasn't just a migration. It meant changing the foundation of every store. Before we talk about the solution, it's important to understand the environment we were operating in. Yes, we had some hard constraints. We had no budget to go and buy the best and the latest hardware. We never wanted to venture into another proprietary software, and our stores being customer-facing had very less tolerance to downtime. To top it up, the pharmacy management system we were using was a legacy Java application built in-house. Rewriting all those into microservices was not feasible in the migration timelines we had. But the real challenge came with the edge environment itself. Each store had limited storage and compute. Network wasn't the best at every store, and there were no platform engineers on site to fix things when they broke. Whatever we had to build had to be done remotely and resilient by default. All these constraints weren't negotiable. They defined the operating procedure for us. And we had to design a platform that works under these constraints, and that challenged every decision we made. The answer was simplification, not replacement. Modernize without new hardware. Eliminate proprietary licensing. Standardize on open source. So we built on what we had. We started with the base of OpenSUSE, and then we installed Kubernetes on top of it. And then we introduced KubeVirt. So KubeVirt was our bridge to let us run legacy VMs inside Kubernetes so that we don't have to rewrite everything as microservices. At the end, every store became a small declarative data center where every component was open source. The goal wasn't Kubernetes here. The goal was to make every store manageable the same way. But architecture is one thing, replacing a live platform is another. To migrate our stores safely, we designed a 4-step process where every step was reversible and rollback was always possible. The first step, the pre-cutover phase, we introduced a third node into the store. And mind you, this is not a new node we bought. This was a node already existing in the store whose workload had been previously migrated to cloud. So we repurposed that node to install a Kubernetes cluster alongside the ESXi environment. Now this gave us a safe way to validate Kubernetes workloads without even touching the production system. During this phase, we also took the opportunity to simplify architecture. We decoupled components from the pharmacy VM. We moved one pharmacy component to a small dedicated VM that was IBM messaging queue. We were also able to modernize or convert 10 pharmacy applications as microservices. So all this helped us to make the pharmacy VM significantly lighter. So from running a pharmacy VM with 32 GB memory, we came to a VM running 18 GB memory. And all this was done to reduce the tight dependencies, which directly aligns with the core SRE principles around isolation and safer changes. Second was the cutover night, and that's a show time. Cutovers were usually done after the stores were closed. We consolidated the workloads on one single ESXi node. That freed up another node, and we expanded the Kubernetes cluster to a 2-node cluster. Data was then synced, and IPs were switched. But one important point to note here is there's still one ESXi node available, which we kept intact with the old VMs, but in a shutdown state. So this gave us a safe end state to the night, where now applications are running on Kubernetes, but we still have an ESXi node in case there are issues and we have to roll back. We never replaced the system in one step. We replaced it in safe layers. The ESXi node here was our insurance policy. Only after the stores confirmed operations the next day, we would go ahead and convert the ESXi node into Kubernetes and make it a full 3-node cluster. The diagram here shows the final state of our stores. The key idea was simple. never make an irreversible change until the new state has proven itself under production load. Now, how did we deploy and monitor these systems? Our deployment strategy was simple: imperative to bootstrap, declarative at a steady state. We used Ansible to bring up the OS and install Kubernetes. After that, everything was Git-driven. The key design decision here was the hub and spoke GitOps model. This allowed us to do controlled rollouts across clusters without overloading Git or the network. So instead of edge clusters polling Git every hour, we introduced a management cluster which acted as a hub. The hub polls GitOps repo, detects changes, and then performs a push-based reconciliation to our edge clusters. Note, the Git still remains our source of truth, but now reconciliation is controlled and centralized. Observability being the core SRE principle was built in from day one. We had OTL collectors collecting logs and metrics, pushing data to purpose-built backends like Loki, ClickHouse, Victoria metrics. Grafana was used for visualizing and alerting. At last, the results were deterministic, repeatable, and we had drift-free deployments across stores. Now, how did we scale to 1400? What made this possible was a small team, but focused. We had a group of 5 SREs who were focusing on platform, automation, and reliability, a TPM managing the program, and 4 deployment specialists who were carrying over the nightly cutovers. The key wasn't the team size here. It was having repeatable, automated processes. We intentionally started slow, migrating 1 store a night to validate our process and uncover any edge cases we might have missed. After each deployment, we used to refine our runbooks, improve our automation, and strengthen our rollback procedures. Once the process was predictable and repeatable, we scaled to around 10 stores per night. And at max capacity, we were doing around 40 stores a week while still maintaining operational safety. The scaling factor here weren't more ingenious. It was better automation and safer runbooks. The impacts of migration were measurable. At last, we could eliminate all licensing cost for OS, virtualization, and monitoring across stores. We standardized the platform across all stores. Reliability improved because of Kubernetes self-healing features. And most importantly, the platform now supports modernization without another migration. The economics and operations both got better. With that, I would want to leave you all with the key takeaways and the lessons we have learned. Applying SRE principles, especially automation, wasn't optional for us. It was a must for such kind of migrations. And what made this migration possible were small but deliberate choices: standardizing the platform, going declarative, using GitOps, and designing every step to be reversible. We kept asking ourselves 2 questions. Can this be rebuilt deterministically? Can this scale without people? And if the answer was no, we would go back to the drawing board. The biggest lesson we learned is modernization isn't about new tools. It's about reducing operational surface area. The discipline of execution matters more than the tech stack, and that is what made this migration work. Thank you, everyone.